Have you ever wondered how skyscrapers stand tall, or how tunnels are built underground? The answer lies in a fascinating field of engineering known as geostructural engineering. In simple terms, geostructural engineering is the science of building structures that interact with the Earth. It's all about making sure that what we build on top of the ground or even underneath it is safe, stable, and built to last. Think of it like this. The Earth is like a giant puzzle, and geostructural engineers are the ones who figure out how to fit the pieces of our buildings and infrastructure into it. They are the unsung heroes who work behind the scenes, ensuring that our world is built on solid ground. Geostructural engineering is a vital part of many construction projects, from small residential homes to massive bridges and dams. Without it, our buildings and infrastructure would be at risk of collapsing, sinking, or being damaged by the forces of nature. Geostructural engineering is a bit like a superhero team-up, combining the strengths of three different engineering disciplines: structural engineering, geotechnical engineering, and construction engineering. Structural engineers focus on the design and stability of the structures themselves, making sure they can withstand the stresses and loads they'll experience. Geotechnical engineers, on the other hand, are the ground experts. They study the soil and rock beneath our feet, determining its properties and how it will behave under the weight of a structure. They're like the detectives of the earth, uncovering its secrets to ensure a solid foundation. Finally, construction engineers bring everything together, figuring out the logistics and methods for actually building these structures on or within the ground. They are the master planners who ensure that the designs of structural and geotechnical engineers can be brought to life safely and efficiently. And one of the most critical aspects of geostructural engineering is understanding the ground itself. Soil and rock are not simply inert materials. They have unique properties that influence how structures built on them will behave. For example, some soils are strong and can support heavy loads, while others are weak and prone to settlement or collapse. Geostructural engineers use a variety of techniques to investigate the ground, including drilling boreholes to collect soil samples, conducting laboratory tests to determine soil properties, and using specialized software to model ground behavior. They also consider factors like groundwater conditions, which can impact the stability of excavations and foundations. By thoroughly understanding the ground, geostructural engineers can design foundations and other structures that are safe, stable, and appropriate for the specific site conditions. Section 4. Applications of geostructural engineering. The applications of geostructural engineering are vast and varied, touching on almost every aspect of our built environment. Here are just a few examples. First, foundations. One of the most common applications of geostructural engineering is the design of foundations for buildings and other structures. The type of foundation required will vary depending on the size and weight of the structure, as well as the soil conditions. Next, retaining walls. Retaining walls are structures designed to hold back soil or rock, preventing it from collapsing or eroding. They are commonly used in road construction, landscaping, and to create usable space on sloped sites. Then tunnels. Building tunnels for transportation, water conveyance, or other purposes requires specialized geostructural expertise. Engineers must consider factors like ground pressure, water ingress, and the potential for seismic activity to ensure tunnel stability. Finally, excavation support. When excavating large areas for foundations, basements, or underground structures, geostructural engineers design temporary support systems to prevent the ground from collapsing. Section 5. Shaping the future of construction. As our world continues to urbanize and infrastructure needs grow, geostructural engineering will become even more critical in shaping our future. New and innovative techniques are constantly being developed, such as using ground improvement methods to strengthen weak soils or incorporating sustainable design principles to minimize environmental impact. Geostructural engineering is also at the forefront of addressing challenges posed by climate change, such as designing structures that are resilient to more extreme weather events and sea level rise. By understanding the complex interplay between structures and the Earth, geostructural engineers are helping to create a safer, more sustainable and resilient built environment for generations to come. Whether it's designing the foundations for a towering skyscraper or finding innovative ways to build tunnels through challenging terrain, geostructural engineering is a field that is both essential and constantly evolving. It's a testament to human ingenuity and our ability to overcome complex challenges by working in harmony with the natural world.